Hello. In this video, we will be discussing introduction of pushdown automata. The topic is the why pushdown automata. Before starting introduction of pushdown automata, why pushdown automata is required. This plays important role for construction of any powerful machine. Okay. Let's move on to the why pushdown. Why pushdown automata? So let us, before discussing why pushdown automata capability, let us see what is drop finite automata for language L is equal to A power n and B power n. In this language, so there is L is generating n number of A's followed by n number of B's. That means, so A will be start first followed by B, right? Is it possible to construct a finite state machine for this? That means always representing the finite state machine in terms of transition diagram. Let us look at it whether it is possible to construct or not. Take one of the state which itself is a starting and final state. So suppose if I take A, it takes a n number of A's and also it reads n number of B's. It accepts a number of A's followed by a number of B's. But what is the language generated by this? Always A start with A start followed by B. Right. But in this case, even B can be accepted followed A. So B will also start first followed A. So both the cases accepted, then it is not possible to construct the finite state machine for this language. Reason is that it has a limited capability and also there is a finite memory, that is a finite memory. It has a tiny memory. No external memory is involved with the finite automata. Because of these two reasons, it is not possible to construct the finite automata for this language L is equal to A power n and B power n. That means finite automata is not possible to construct every languages. Some certain languages require some memory, right? Such possibility is not available. Such capacity is not available in finite automata. That is the reason the pushdown automata is chosen as compared to finite automata. The finite pushdown automata is powerful as compared to finite automata. Let us see that now in the next slide. Pushdown automata as a finite state control and is as accepting a input and producing as in terms of accept and rejecting state. It's just like the finite automata. But what is there? What is the special feature is added for pushdown automata is a stack data structure. Stack has the capacity to store the intermediate result that can retrieve it later for the later requirement, right? Because of this reason, the pushdown automata is very powerful than finite automata. So it has additional feature is a stack alphabet intermediate storage, because that you can able to solve some complex problem, complex languages like L is equal to A power n and B power n. That means PDA can write unbounded number of symbols on the stack and also it can read it later. And writing a symbol on the stack is called push operation and removing a symbol of the stack is called pop operation. So this you can, as long as you wanted to push a element onto the stack, you can use the push operation. As long as you wanted to read it or remove symbols from the stack is called using a operation called pop. This will gives the clear feature of pushdown automata. What is pushdown automata? How pushdown automata works and is like works like a finite automata. What will be the special feature as compared to the finite? In this slide, you will go into study what is the definition of PDA. Usually PDA is defined by 7 tuple which is denoted by M, that is Q, sigma, tau, Q, Z, F, delta. Then you can describe like this. These are all the symbol, few of the symbol you already seen in finite state machine, that is Q, capital Q, sigma, Q, then F and delta. Only these two, tau and Z symbol, has not seen in any of the previous machine pushed finite state machine. These two special symbol will be using it for it makes these two symbols more powerful PDA. The Q is a finite set of state, sigma is a finite set of input symbol, tau is a stock alphabet, Q is the initial state, is an element of Q, Z is the initial stock symbol, is an element of tau. F is a final set of accepting F is a set of accepting state, is a subset of Q. There is another notation called delta, is a transition function which is different than the finite state machine. It has the two transition function in terms of DPDA and in terms of NPDA. Look at the DPDA. There is a 3 parameters will be deciding whether you have to go to the next state or you have to push some element, push or pop some element onto the stack. What are those 3 elements? So this explanation is like this. You are at the one of the state is a set of capital Q is a set of state. You will be in the one of the state. You will looking at some input symbol, either input symbol from Q or you can see some empty symbol. At the same time, you look at the what is the top of the stack, right? What symbol will be in the top of the stack? Based on this parameter, you may go to the one of the state, or at the same time you are pushing some of the element or popping it, or you can retain in the same state of the stack. Similarly, NPD also, based on these 3 parameter, you will be in the one of the state. You will be reading some input or you can take a empty symbol. At the same time, looking at the top of the stack. Based on that, you move on to the 2 different state. That means you may go to the 2 different state or pushing or popping any element onto the stack. These 2 are deciding the transition function of DPDA and NPDA. So you will understand clearly when solving some problems these 2 transition function. Now we will move to the next topic is how this DPDA can represent by using a graphical way. There is a finite control as you like in a finite state machine. Here in PDA also has a finite control. Then you can have a input tape, that is each tape, the tape is divided into each cell. Each cell has, that is finite control as have a pointer to the input tape. At the same time, PDA also stack is also has some pointer, that is a stack head, which you can looking at what symbol at the top of the stack. At the same time, it is also other pointer is looking at what symbol you are reading from the top input tape. So based on this, you are keep on process the language complex problems. So that is each one of the element will be discussing in the next slide. Right. So there is a tape. As you have seen in the previous slide, the tape is like this. Each tape is divided into finite cell. Then each cell contains the symbols. Look at that. Each of the cells contains some input alphabets, right, which is comes from this. Right. Similarly, there is another component which associated with the finite control, that is a stack. Stack is always scan the top of the scan, right? It perform two operations. One is push, add a new symbol onto the add a new symbol at the top, or it can be write a symbol onto the top, or you can push a symbol onto the top, right? Another operation called pop, it can read and remove the top symbol from the stack. So this can be stock symbol is represented by tau. So there is another important operation is how the input is read from the input buffer. That is, the 8 always scan from the left to right, and each can read it one symbol at a time, right? It will not read entire symbol from this input buffer. It can read one symbol at a time, and the pointer it can move to the left or move to the right. So like this, you can read the each symbol from the input buffer. Then what is this point? Once we understand the overall structure of PDA, let us understand how the PDA can accept. So there are two different ways to define PDA acceptability. There is one acceptability is called final state acceptability. Final state acceptability. That means you read entire string, reach to the final state, irrespective of the what symbol is there on the top of stack, you can say accept final state acceptability. So that is another way of acceptability is empty stack acceptability. That means read entire input from the input tape, and at the same time stack is become empty, then you can say accepted. You can say accepted by empty stack. That means so you need not to reach the final state. So like that. So we'll see the definition of final state acceptability. The PDA accepts a string when after reading the entire string the PDA is in final state. From the starting state we can move that end of in a final state with any stock values. The stock values are irrelevant as long as we end up in a final state. I just 2 minutes before I explain that, so that what is the meaning of this entire statement. That means you have to read entire input from the input tape at the while at the same time you are in the final state, irrespective of what symbol is there on the top of the stack, then you can say final state acceptability. In other way, so PD accept entire string from the input tape, then so at the same time you have to make the stack as an empty, nothing is there on the top of the stack, then irrespective of whether reach the final state or not, then you can say it is empty stack acceptability. These two are, I will be clear it while solving or designing a PDA better way. So while solving a problem, you'll understand that how do you make the final state acceptability, how do you make the empty stack acceptability. Both are valid. You can retain any one of them for your designing a PDA. So you need not to maintain two acceptability. Either one you can be maintain it while solving the problems. So with this, we'll move on to the. Okay, in this, how to represent PDA? How to represent PDA? The PDA represented in a transition diagram. So look at this. So A is a input, on top of the stack is Z0, pushing A onto the stack. And similarly, there is A is a input, top of the stack is A, pushing A onto the stack. So once as long as A is seen in the input, keep on pushing onto the stack. Then once A is over, other symbol comes like B. B is a input, on top of the stack is A, pop it. Right? It will be moved to the next state. Then what are these parameter will representing here? The push operation as taking of the two symbol, and pop a, even you can push A onto the stack. So write input is A and stock symbol is Z0 and pushing it. So this way you can represent the PDA in the rest of the PDA construction. Okay. So let us sum up the how this logical works for this language design TPDA for L is equal to A power n and B power n such that A comma B belong to sigma n is greater than 0. So this is for taken for only example purpose, that is how to demonstrate the logic behind this. So first you take one of the language A power n and B power n. If n is equal to 3, then what will be the language? Then A power 3, B power 3, that is equivalently 3 A's followed by 3 B's. So how to store this, how to process this input? There are 3 A's starting followed by 3 B's, right? Just you have to, as you are told there is always stack plays important role processing this input. You take the stack, so it is stack cancelled. On top of the stack is Z, then top of the stack is Z, then what is the input is here? What is the input is here? A. So keep on pushing. A is 1A is pushing onto the stack. What is the next symbol? The input buffer, input pointer is moved to the next symbol, that is also A. On top of the stack is also A. Input is A. Then you have to push it. So then second A is over. Again input pointer is moved to the third A. Then what is the top of the stack is A. Again push onto the stack. Right. Then reach to the next symbol. Next the input pointer move to the next symbol, that is a B. So what is the top of the stack? A. Then you have to pop it. So again input pointer is moved to the next symbol. Then what is the top of the stack is A. Then you have to pop it. Right? You have to pop it. Then again input pointer move to the next symbol, that is a B. What is the top of the stack is A. So then again you have to pop that. What is the next symbol? Again input pointer move to the next symbol, that is epsilon. So what is the top of the stack? Z. So then you have to stop it, and at the same time you are reached to the final state, say accepted. This way you have to be clearly apply the stack operations and process the entire string. Then it is easy for you to design the pushdown automata. So this is for example purpose I have taken. Similar example I have taken for in next video, how to solve this this problem, how to construct a transition diagram and also transition function in this next video. Okay, in this we'll also cover it at the application of PDA. The application of PDA is also important for while learning the PDA pushdown automata. So the first application is plays important role while implementing a context free grammar. So that's very important. And another application is PDA is used in a parser design for syntactic analysis. That means it is a role, plays an important role in compiler design, that too in a second phase of the compiler. So these two are plays important role for designing a compiler. The PDA is as a more powerful machine. Okay, thank you. We'll see you in the next video.